So we're going to go over the solar system. You guys created the solar system chart using the posters that are in the hallway, or you use the internet. The posters are still hanging up in the stairwell if you want to use them. But let's go through our solar system and make sure that we understand. Sol, or sun, okay, so our solar system is based around the things that orbit our sun. Okay? The solar nebula theory basically describes the idea of how our solar system formed from a nebula, and that the whole solar system started to form 4.6 billion years ago. Okay? That's important because that's also the age of the Earth. Okay? That creates everything in the solar system at roughly the same time. So what makes stars and planets different? Okay, stars are going to create their own energy, like our sun creates energy using nuclear fusion in the core, which comes out as heat and light, but the planets actually reflect that energy. Our sun is the center of our solar system, and all the planets revolve around it. We get our energy from the sun. Okay, so plants, all the different ways that we have energy here on Earth, they actually originate at the sun. So inner planets are called terrestrial planets, okay? And there are 4 of them. Inner planets are rocky planets in general. They're small, they're dense, they're mostly solid, they have few or no moons, they have little to no atmosphere, and they have short orbits because they're closer to the sun. Okay, so the planet that's closest to the sun is Mercury. It's solid and covered with craters, and it has almost no atmosphere. It's the smallest of all 8 planets. And remember that I'm saying 8 and not 9 planets here. Okay, then we have Venus, and this one is sometimes called Earth's twin because it's about 3/4 the size of Earth. A lot of people think that Mars and Earth are really close in size, but Mars is actually smaller. Okay, Venus is what we call Earth's twin. The surface is rocky and very hot, and the atmosphere completely hides the surface and traps the heat. It can also have acid. We assume that it's going to then have acid rain and stuff like that because of the way that it has this really thick and sort of scary looking atmosphere. Earth, okay, is the 5th largest planet, but it's the 3rd from the sun. Like that song, like third rock from the sun, right? Like that's because that's where Earth is, okay? Liquid covers 71% of Earth's surface, and it's the only planet that we know of with oxygen in a gaseous form, which makes it able to support life. It's what's called the Goldilocks zone. It's that area, that distance from the sun where it's warm enough to keep the planet hot, but not so warm that it burns everything up. Yeah?
So when the sun starts expanding after the fusion stops, the Goldilocks zone will move back?
Yes, absolutely. The Goldilocks zone moves with the size of the sun as the size of the sun increases. So it is entirely possible that Mars will become part of the Goldilocks zone at some point when the sun turns into a red giant. Yes, absolutely. Which is just one more reason why it might not be a terrible idea for us to consider trying to create a colony on Mars. All right, so then let's talk about Mars. Mars has a very thin atmosphere that contains mostly carbon dioxide. So while plants would flourish there, we would not, right? Because that'd be poisonous to us. But if you could get enough plants there, you could get enough oxygen in the air, okay? Mars has 2 small moons, Phobos and Deimos, and there's evidence that there was once water on Mars, meaning that it could have contained life in the past. We're still not sure whether or not it did, but it definitely has ice right now. So between the ice now and evidence of liquid water in the past, and we'll talk more about how we have that evidence later this year, but that's really important information because it means that at one point, Mars, which does sort of run up against the edge of our Goldilocks zone, which is not like a real place, right? It's just an idea, perhaps was sustaining life at one point in the history of the solar system, which is 4.6 billion years, which is a long time, and it's totally possible. All right. So in between Mars and Jupiter, separating the inner and the outer planets is the asteroid belt. This seems to be a place where there should be another planet, but there isn't one. Now, there are different theories about this. Some say that it didn't form there because Jupiter's gravity was so strong that it prevented the planet from actually solidifying and creating its own center of gravity. Other theorists say that there was another planet there, perhaps there were two other planets there, and that they crashed into each other and they broke up into all these little pieces, creating the asteroid belt. We don't know, okay? We just know that it exists there and that it's rocky, which means that theoretically, if it had formed, or if it was a planet in the past, it was probably another terrestrial or rocky inner planet, okay? But the asteroid belt separates the inner planets from the outer planets, because starting with Jupiter, our next planet, we're getting into what we call the Jovian, or outer planets, where they are very large, mostly gas, they have lots of moons, because they're so much bigger, they have a lot of gravity, which attracts those moons. They have hydrogen and helium atmospheres, which makes them more similar to the sun than to our planet, for example. They're very low density, and they have really long orbits, and that's because they're so far away from the sun. Jupiter does not have a solid surface. It's basically a liquid ball surrounded by gas, and the Great Red Spot is a huge storm of swirling gas that's lasted for hundreds of years. You could fit 4 Earths in that little spot, right? Jupiter is enormous, okay, so that's really important. There are at least 67 known moons, the most famous of which are the 4 Galilean moons, named after Galileo, right, who discovered them. Yeah?
Is there like an estimate for how fast the winds are in the Great Red Spot?
I am sure that there is, but I don't know it off the top of my head, and I can certainly find out for you. But yeah, yes?
What if a planet tried to form an asteroid belt, but it got pulled in by Jupiter and became one of its moons?
That's totally a reasonable thing that could have happened. Absolutely, that's a thing that could have happened, for sure. Jupiter is the biggest planet in our solar system. It's not the biggest object, right? That's the sun, but it is the biggest planet. Jupiter's 4 largest moons are pretty important because they have things on them that make them also seem like they could be lifelike for us at some point, or habitable. So Io has active volcanoes. Europa has a lot of ice, which is cool, and there's recent evidence that shows there might be oceans underneath the ice on Europa. Ganymede, it's the largest moon because it's almost as big as Mars, which is enormous. Callisto is, I don't know how they know that it's the oldest, but it does have a lot of craters on it. Callisto and Ganymede may also have salty oceans underneath their crust, and we don't know, right? There's a lot of options here because we have visited there with satellites, but we've never sent a person there, and so we can't observe all these things ourselves.
How do you know that they're there?
The moons?
Yeah.
You can see them.
The telescope.
Telescope.
Oh.
Yeah. All right. Do we need to have like a telescope session where you guys can actually like look up? Have you never seen planets and moons in a telescope?
No.
Some of them you can see with the naked eye.
Some of them you can see like but they're little dots, but like literally you can see the rings on Saturn through a telescope. Okay, yeah. We'll have a good telescope night. Hang on. I will plan a night, and I know that not everybody will be able to come, but we'll plan a night with a good telescope and get you guys to be able to see some of this stuff. It's very cool. All right, Saturn is the second largest planet. Look at how it's tilted, right? This is a really great model because the rings are very obvious on Saturn. All of the outer planets have some kind of a ring system. They're just not obvious. This one has a lot of ice in its rings. Saturn has a lot of ice in its rings, and that's why we can see the rings because they're reflecting the light from the sun. Saturn is super, super, super low density. So Saturn would float. If there was a lake big enough for it to sit on, Saturn could float because it's really low density. And the rings are not solid rings. They're like belts of ice and stuff that's going on around the outside of them, but they stay confined in that little disc. Okay? All right, Uranus also has rings. It's the 3rd largest planet, and it spins on its side, which is super cool. You can tell by where its rings are that its tilt is actually this way. So it's got like a nice horizontal tilt to it. And it's blue-green because it's got a lot of methane in its atmosphere. So methane is similar to the stuff that we would use to like cook our food on the stove. Yeah.
Is there like, I've heard there's like a theory to why Uranus spins on its side.
There's a lot of different theories, and you can absolutely look up a bunch of them. We don't know for sure why any planet spins in any particular direction, but we have ideas, right? We can't say for sure because we weren't there when it actually happened to start with, but that's a good point. And there's a lot of the planets, there's so much cool stuff about them, you guys. All right, Neptune, which is the farthest out planet, is the 4th largest planet, and it's the 8th planet from the sun, so it's the last planet in our solar system that's considered a full-size planet. Because of the way it orbits, Neptune was the 9th planet for a while, because back from 1979 to 1999, Pluto was still considered a planet, and their orbits actually crossed each other, because remember, everything's in elliptical orbit, but that orbit was sort of tilted, and because it was tilted, it actually like crossed and was inside. The orbits are so long that it takes many Earth years for them to have a single year on the planets that are farther out. So that's just something to keep in mind. Neptune is also sort of a blue color because of the amount of methane. And we know this because of the satellites that we've been able to send out there to do observations and flybys of the planets. Now, a lot of people want to talk about Pluto being the 9th planet, and sometimes it's a planet and sometimes it's not a planet. The reality is that science is ever evolving as we learn more information. Okay, it's sort of like the idea that we used to think that there was such thing as a brontosaurus, but it turned out that we just put 2 different dinosaur skeletons together by accident and didn't realize it. Okay, so that happens. And in the case of Pluto, Pluto is breaking too many of the rules of being a planet. Look at how its orbit is, right? So Pluto is actually considered part of the Kuiper Belt, okay, which is a whole bunch of rocky things that are out there, and there's a lot of other Pluto-sized things. Pluto has its own moon, which is why it was considered a planet for a long time, but it's not big enough to be classified as a planet, and it cannot clear its own orbit because, oh yeah, Neptune. Yeah?
Isn't there like a big storm also on Neptune?
I could not say. That would not surprise me because it's also a gas-based planet, right? And that's why they can also sometimes be called gas giants. All right, so that there's other stuff in our solar system: comets, meteors, asteroids, the Oort cloud, and we'll get into that in our section next class before we do the lab. But for now, we're going to pause where we are, and I'd like for you to complete the middle section of page 38 and do your Venn diagram for the inner versus the outer planets. You can use your solar system chart to help you. All right, good luck.